Hey guys, today we're going to be talking about ions. Let's get started. Okay, so first thing we need to know is kind of the difference between what is an atom and what is an ion, and we're also going to briefly talk about kind of protons versus electrons. Here we go. So in an atom, you have these things called electrons. Now, how electron works in an electron, or in an atom, what its purpose is to determine reactivity. Now, it's not as simple as the more electrons you have, the more reactive are, or the fewer electrons you have, the more reactive you are. It's actually based on how full your outer level is. So remember in the Bohr model, we said that if you have, for example, two electrons, your first energy level is full. If you have eight electrons in the second energy level, that's full. And if you have eight electrons in the third energy level, that's full. So when an atom is stable or not very reactive, that's when it has a full outer energy level. So let's say it's got electrons in its first and second energy level. What an atom will want to do is it'll want to get up to eight electrons in that second energy level. Or if it's easier, let's say maybe it has to like gain two electrons to get to eight in its second energy level, that's easier for it. But if it only has like a electron in the second energy level, maybe it'll just lose that so that its first energy level is full. So that's how atoms ionize, is they change their number of electrons. Remember, a proton determines the identity of an atom. So we will not see protons change here. Electrons are on the outside. They're easy to add or remove compared to protons. So we will see electrons change. That doesn't change the identity of an atom, but it will change the charge because remember, electrons are negative. So in an ion, it's going to have the same number of protons as an atom, but it's going to have a different number of electrons. That's the key with an ion. Same number of protons, different number of electrons. And then remember, because a full outer energy level is stable, atoms are going to ionize, atoms are going to become ions to become stable. So I wanted to show you, here's a picture normally of lithium. Lithium has three electrons. So notice here, its first energy level is filled, and its second energy level, it only has one electron. So in order for lithium to become stable, it's going to want a full outer energy level. It can either do that by adding 7 electrons around the outside of the second energy level here. That's kind of hard to do. It's going to be hard to grab 7 different electrons. Or what it could do is it could just remove this one electron. And that's actually what we see happen. We see that a lithium ion is actually Li1 plus, meaning we removed the extra electron in the second energy level, and now we have a filled first energy level. So notice because an electron is negative, I'm getting rid of a negative, so I become more positive, right? Another way of thinking about this, I have 3 protons, 2 electrons. Each proton is +1, so +1, 2, 3. I've got +3 versus I've only got -2. Hopefully that makes sense how ions form and why they form. Let's move on here. This is just a little graphic. What I wanted to show you here is I wanted to show you how adding electrons is negative and how removing electrons is positive. Those are two pieces of information to write down in your notes. Adding electrons makes a charge negative. Removing electrons gives you a positive charge. So let's say that I have, in both these cases, I've got 5 pluses and 5 minuses. So this would be the same thing as 5 protons and 5 electrons. Right now, these are both just atoms. However, what I can do here is if I add an electron, now I've got 6 electrons and 5 protons, so my total charge here is going to be -1. If I add a second electron, -2. Add a third electron, -3. And then add a fourth electron, -4. Same thing would be true if I were to remove an electron. Here I'm removing an electron, and now my pluses outweigh my minuses. So I've got a +1, a 2, or a +3, or a +4 charge. So hopefully this makes sense if you think about it just a little bit more. If you think adding electrons, you might think adding, oh, that's positive. That's where a lot of kids get tripped up here The idea here is that you're adding something that's negative, so you're going to have more negatives than you have positives. Or if you're removing a negative, you're going to have more positives than you have negatives. So removing electrons is positive, write that down. Adding electrons is negative, write that down. Here are two example atoms that chlorine adds an electron, so it becomes negative, and sodium is going to remove an electron, so it's going to become positive. We have different names for those. Here is what we call cations. Cations are positively charged ions. I like to think of them as positive, like a cat has got paws. Um, yeah, anyway, so you'll notice that here the sodium ion is losing an electron and it becomes smaller as well. That's kind of a fun fact. So yeah, that's just what they're saying. This generally happens for metals. Metals lose their outer energy level, and then they'll have more protons than they have electrons. That's kind of what we're saying here. So here's an example with lithium, or actually, sorry, we'll do the example with magnesium. So here's magnesium normally with its 12 electrons. It's got 2 in the middle, 8 on the second energy level, and 2 on the third energy level. So these 2 electrons in red are the electrons magnesium is going to lose. Once it does that, it's got no third energy level, so its outer energy level now is the second energy level. That has 8, so it's stable, which is great. That's what an ion wants to be. But then we'll notice that we have 10 electrons, 8 on the outside and 2 on the inside, versus 12 protons. So in this case, magnesium is going to have a charge of 2 plus. So we would write down Mg, and then we write down 2 plus as a little subscript there, just kind of up in the top. Anions are kind of the opposite of a cation. They're negatively charged ions. So there's Anne Hathaway being negative. I thought that was funny. These are typically nonmetals, and they're going to have more electrons than they have protons. So here is just a regular chlorine atom with 17 protons and 17 electrons. It's going to gain an electron to have 18, or 8 in that third energy level, so that's super stable. Yeah, that's an anion, negatively charged ion. So you're going to want to know that cations are positively charged, and you're going to want to know that anions are negatively charged. And how I remember it is cats have paws, so they're positive, and anions are negative because an is negative. Here's what oxygen looks like. Oxygen has 8 electrons, and it also has 8 protons. So here I've got 2 in the first energy level and 6 in the second energy level. 2 plus 6 gives me a total of 8. I want to have 8, though, in my second energy level. So to do that, I have to add in 2 electrons. Here are the electrons that got added in green. So now I've got a total of 10 electrons, and I've got 8 protons. So oxygen is now going to have a -2 charge. That's its charge right there, -2. And oxygen now is stable because it's got that second energy level fully filled. Here's another example of phosphorus. Phosphorus has 15 electrons and it's got 15 protons. So right now it's stable. Right now it's got 5 valence electrons. So the question is, how many electrons will be added? What do you think phosphorus's charge is going to be here? Hopefully you figure it out. It's got 5, it wants 8, so it's going to need to add 3 more. That's going to give us a phosphorus with a charge of -3. This is just kind of a little meme that I use to help remember cations are positive and anions are negative. I think it's funny. Here's a quick little tip to help you with the periodic table. Everything in the first column over here are all +1. Everything in the second column over here, always +2. If you have 3 valence electrons, if you're in column 13, you're going to have a charge of +3. Carbon and silicon don't really form ions, so maybe just ignore that. We'll say for our purposes that they could be positive or -4. Just because they have 4 valence electrons, they could either add 4 valence electrons or they could subtract 4 valence electrons. They're both easier. If you have 5 valence electrons, you want to gain 3 electrons, so you'll have a -3 charge. If you have 6 valence electrons, you're going to want to have a charge of -2. And if you've got 7 valence electrons, you're going to want to have a charge of -1. If you're over here in column 18, you already have 8 valence electrons, so you will never have a charge. Helium, neon, argon, krypton, xenon, those all don't have charges. So hopefully this is a quick little thing you can just write down across the top of your periodic table, and then on the homework when it asks you oxygen, what charge does it have? You just have to look up and say, oh, it's a -2, just like everything else in this row. So that's a little cheat sheet for you. But this maybe doesn't really explain exactly kind of how things get its charges. Um, yeah, but hopefully that helps. And then remember here, I'm writing 8 VE just so you know that the charge here is 0. There's no charge here. It's not a charge of 8. Great. Okay, that's all I've got for you guys today. Have a great rest of your day. We'll see you next time.